Okay, so now on 6. The problem with trying to just let the 2x be u is if I do that, I'll have a 1 over 1 plus square root of u in the denominator, and that's not going to be very helpful because I can't split that. So I'm going to try something else. And how about we let the whole denominator be u, because it's nice to just, if I'm going to have a denominator, I'd like to just have a u in it. So now when I take the derivative, of course I have to power that down. So it'll be a 1/2, and then power down to a negative 1/2. That is a negative. And then take the derivative of the inside. And now keep in mind, I can only reduce this pair of 2's, not this one, because this one is actually underneath a radical. So this is really 1 over radical 2x dx. So when I look over here, I'm going to have 1 over u, and now, head scratcher, I need a square root of 2x in order to get that dx to be transferable into du. So I'm going to multiply by 1. And now all of this will turn into du, but I still have that square root of 2x, and I'm not allowed to integrate until all the variables match. So I have to figure out, well, how can I substitute in for square root of 2x? And if I go back and I look at my original, I go, oh, I could get square root of 2x by itself. If I got square root of 2x by itself, I would have u minus 1. So now it's going to turn into a u minus 1 on top. Ooh, this is perfect, right? I can split it now. So I'll have u over u minus 1 over u, and I can do each of those separately. As a matter of fact, I'll just slip another integral sign in there. So of course this one is 1, and the antiderivative of 1 with respect to u is just u minus natural log of absolute value of u plus c, and then I'll go back. I'm almost there, and I'm going to substitute back in for u. So there's the first one, minus natural log 1 plus square root of 2x there also, plus c. Perfect. So again, I don't want to have any sums or differences in denominators. So I'm going to let the denominator be u. And then if I take the derivative of it, the derivative is negative sine x dx. So I need to put a negative in there and a negative out front to compensate for that negative, because I'm really multiplying by 1. And then I note, yay, all of this is replaceable with a du. And now the bottom is just u, so when I take the antiderivative, 1 over u is going to turn into natural log of absolute value of u, and of course I can plug back in the 1 plus cosine x. Okay, watch this trick. Synapse is getting blown. Remember, this negative can go back up. And so if I do that, it's going to turn into this. And I'll put the cosine x now on bottom, because it would have a negative 1 exponent. And I would like to know that in case the multiple choices don't match my first selection. All right, see you in the next video.